Hello and welcome to the GCSE Physics tutorial for topic P5 forces. This tutorial is part 5 and will look at forces, acceleration and Newton's laws and momentum. First of all, you need to know what terminal velocity means. This means the maximum speed an object can move at, and different objects have different terminal velocities. It occurs when an object falls. Remember that gravity at first is larger than air resistance. But as the speed increases, as it starts to fall faster and faster, air resistance also increases, and so this reduces acceleration. When the resultant force is zero and air resistance equals gravity, the object has reached terminal velocity, so it won't go any faster, as shown in the graph here. Now, a common example is to show terminal velocity in a skydiver. Now remember, on Earth, terminal velocity depends on air resistance and gravity. Let's look at this skydiver. First of all, when he jumps from the plane, at first he accelerates, and so you can see the speed increases. As he speeds up, the air resistance will start to increase, and when air resistance and gravity are the same, then the speed is constant and they've reached terminal velocity. That's the first terminal velocity. Now this will change again because then the skydiver will open his parachute, and when they do, the air resistance will slow the skydiver down, and they'll continue to slow down until air resistance and gravity are equal again, and so a new terminal velocity is reached. You also need to know about Newton's three laws. The first law is that if the resultant force on an object is zero, then the object will remain stationary. If the resultant force on a moving object is zero, the object's moving at a steady speed. If the resultant forces are not zero, then the object is going to be unbalanced, so they can accelerate or decelerate. So this example here would show acceleration. The second law is to do with force, mass and acceleration. The larger the force, the more an object accelerates. The larger the mass, the less it accelerates. Force equals mass times acceleration. The third law states that when two objects interact, the forces they exert on each other are equal and opposite. You need to know about a practical where you would investigate motion, as shown here. This practical can be used to look at the effect of mass or the effect of force on acceleration. If you were looking at the effect of force, you would set up the equipment as shown, and you would add different weights to the pulley here. So this would change the force on the glider here. And then each time you would time how long it takes for the glider to move between these two light gates. That will be able to give you the change in velocity and the time, and so you can also calculate the acceleration. If you wanted to see the effect of mass, you would add different masses to the glider, but keep the forces here the same. And you would repeat the experiment. What you would find out is if you add more masses, the object accelerates less. But if you add more force here, the object accelerates more. You need to know about stopping distances. A stopping distance of a car or a vehicle is the thinking distance plus the braking distance. Thinking distance is how far the car travels between when the driver thinks they have to stop to applying the brakes. And that can be affected by how fast they're going, but also affected by their reaction rate, which is affected by things like drugs, eyesight, tiredness, etc. The braking distance is how far the car travels from when you apply the brakes to when it stops. And that's affected by how fast you're going, the surface of the road, for example, if it's icy and you glide, the weather, the condition of tyres, and the condition of the brakes of the car. Momentum. The momentum is mass times velocity. So the bigger the mass and the bigger the velocity, the more momentum an object has. And in a closed system, the momentum before a collision is the momentum after a collision. Cars have safety features that allow passengers to slow down over a longer time. That means it takes longer for a change in momentum, and so there'll be less force, and so there'll be less severity from an injury from a crash. The three things that cars have to allow this: airbags, this slows down the passenger more gradually when they crash. A seatbelt increases time for the passenger to stop, and a crumple zone, as shown in this car at the front and the back, increases the time taken for the car to stop. If you pause the tutorial now and try these questions. What are Newton's laws? If the resultant force on an object is zero, the object will remain stationary. If the resultant force on a moving object is zero, the object will move at a steady speed. If the resultant forces are not zero, the object will accelerate or decelerate. Force equals mass times acceleration, and when two objects interact, the forces they exert on each other are equal and opposite. What are the factors that affect stopping distances? Well, thinking distance is affected by speed and reaction time, and braking distance is affected by speed, weather, the car condition, and the road surfaces. What are the safety features of a car? Crumple zones, airbags, and seatbelts. What these do, remember, is they all allow the passenger to take longer to slow down after a collision, which means there'll be less force and less injury. In summary, we've looked at forces, acceleration, Newton's laws, momentum, and the practical investigating motion.